Hello. Good morning. My name is Dhritiman Chakrabarti, and I'll be taking a class on descriptives for statistics. Now, as you know, that major point of observation of your descriptive as well as analytical studies is to describe the data that you have gotten, right? So description basically means that you provide some sort of estimates that will help the readers or the viewers to get an idea of how your data is distributed. Like suppose if you collect heart rate data, the heart rate data can be ranging from anywhere between 40 maybe to 200, right? Now, if you have a number of data points, like suppose you have 100 data points, all of them ranging somewhere between 40 and 200, right? So you will basically be hard pressed to describe to readers that, okay, first patient was this, second patient was this, third patient was this, and so on and so forth. So it's completely pointless to describe each and every data point to a viewer. They will quickly lose interest, right? The other thing to do, you can basically maybe group them into bins. Like basically data can be changed, modified to reflect like maybe 40 to 50, this many people were there, 50 to 60, this many people were there, and so on and so forth. Now, the problem with this approach is that first thing is that you lose information definitely, but this is still a very cumbersome way of describing data. So the easier thing to do that statisticians usually do, and as is regularly seen in all of the journal articles that you will be reading, is that you describe it using some specific form of summarization measure. Okay, so the summarization measure can maybe provide you that, okay, this was maybe the data point that had the most number of people associated with it, or this was the middlemost data point of your entire data series, or around, or the data was this much dispersed, like basically this was the middle point, and about the middle point the data was this much dispersed. Now all of these have some specific nuances to them that I'll be talking about, but before that I'll also be talking about the types of variables that you will be encountering when you're doing data analysis. Okay, so for that I'll be sharing one PPT. So let's just get started with that. So sharing my screen, share. Okay. So, yeah, so types of variables and descriptive statistics. So types of data, like if you go through any this same chapter on in any of the books or any other platform which will be telling you about this, they'll be giving you a plethora of number of types of data, right? But when you talk from a statistical perspective, like what you are actually concerned with, broadly, there are only three types of data, sorry. Okay. Now, let's just understand that. Now, the first thing is that there are two specific parameters, you can say, that you need to think about when you're describing the data. Okay. First is whether there is a definite order in the data or not. Okay, like suppose you talk about genders. Okay, you've got male and female. Now, whether do you have any way of saying that, okay, male is more than female or female is more than male? No. So basically, this data, the gender data, does not have any order associated with it. Similarly, let's talk about religions. Suppose Hinduism, Christianity, Islam, etc., etc. Right. So in that, there is no qualitative way of ordering them in a specific sequence. Right. So as long as there is no order among the data that you have, then it is called a nominal data. Okay, so nominal basically means name, by name. Okay, so basically you're describing the data as just by name. There is no specific order in them. And this is one type of data, this is another type, this is another type. That's all. Okay. Now coming to the other type in which there is an order. Okay. But the differences between each of those levels of the order are not constant. Suppose we talk about suppose education. Okay, so education you can maybe code it out as uneducated, didn't attend school at all, or primary school achieved, higher secondary achieved, graduate achieved, or postgraduate achieved. Okay, so in this there is a definite order among the levels, like it's constantly increasing the level of education, right? But there is no way of saying that, okay, the difference between your this primary and higher secondary is the same as the difference between graduate and postgraduate. You cannot just say that, right? So this type of data in which there is an order, a defined order, but the difference between the levels of the order are not constant. Okay, this will come under ordinal data. Now, other examples of the data that you will be more familiar with is, suppose, like VAS. Okay, this VAS for pain, or NRS for pain, or anything like that. So in that, you know that VAS is scored between this visual analog scale. It is scored between 1 to 10. Okay. Although they are defined as numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the perceived difference between 1 and 2 may not be the same as difference between 5 and 6, and may not be the difference between 9 and 10. Okay. So because of that, you have got a defined order in the data, but the difference between the levels is not constant. Okay, so this type of data is called ordinal data. Now let's come to the last one, in which the difference between each of those levels is exactly the same. Let's talk about a data like heart rate. Okay, heart rate, in the heart rate, you will have a heart rate, suppose 45, 46, 47, 48, 49, 50. Okay. So difference between 45 and 46 is exactly the same as difference between 49 and 50. Will be exactly the same as difference between 140 to 141, so on and so forth. Right. So this type of data is called interval scale data. Now, why is it important? Because most of our analysis is based on the type of data that you have. Most of the models that you'll be working with, most of the group-based analysis that you'll be doing, whatever you'll be doing, everything will be based on the type of data. So interval, in which there is a defined order, as well as the difference between the levels is exactly the same. Ordinal, in which there is a defined order, but the difference between the levels is not the same. And lastly, nominal, in which you do not have a defined order at all. Okay. Now let's come to description of the data. Now for description of the data, usually what we tend to do is we tend to define the data, a data series. That's what we call it. We try to make it into one measure, which is going to describe the central point of the data, and one measure which is going to describe the dispersion around the central point of the data, how much the data is like spread out. Okay, so a measure of central tendency and a measure of dispersion. Okay, now for interval data, you can have this measure of central tendency as mean, median, or mode. Mode is actually not commonly used. It can also be used for nominal data and so on, but it is not a very useful measure for most statistical analysis, so we'll not be talking about that. Next is mean or median. Mean basically means the average. You know, like you add up all of the data series and divide that by the number of the data series, the number of constituents of the data series. So that is your mean. You know what mean is. Most of you are postgraduates, so you know everything. Next, coming to median. Okay, yeah, the median, the median basically means the middlemost data point, middlemost, right? Now, in a series between 1 to 10, the middlemost data point is 5, right? So if you have got 1, 1, 3, 3, 5, 5, 10, 10, 9, 9, 8, 8, so on and so forth as a long data series, the middle point of that is 5, so that is going to be your median. Okay. Now, coming to the next one, in interval data, you can have a measure of dispersion. Okay, so dispersion can have multiple ways of describing it. You have got something called dispersion itself. You have got variance, you have got standard deviation, you have got percentiles, quartiles, interquartile range, just range, minimum to maximum, whatever you call it. There are many different ways of describing dispersion. We'll be going through each of these in a subsequent lecture. For now, I'll just be telling you about what are the different ways of describing the data. Okay. Next, coming to the ordinal data. Now, because the ordinal data doesn't have any defined difference between the levels, so you cannot really describe it using this mean, because the difference between the levels do not mean anything. So the mean cannot be used for describing that data. The most common way of describing this type of data would be median or mode. Okay. Next, the measure of dispersion for ordinal data is always going to be interquartile range or range. Okay. Range is not very useful. Interquartile range is the one which is most commonly used. For nominal data, because there is no defined order among them, median doesn't mean anything. So basically, you'll be either describing the data as numbers, like this many were Hindus, this many were Christian, this many were Islam, or you'll be also describing it as a percentage or proportion of the entire data, meaning that suppose 70% were Hindu, 20% were Christians, and 10% were Islam, and so on and so forth. Or you can also use the mode, but that is rarely used, so we'll not talk about that. Mostly percentages and proportions are used. Okay. Now, all of these things are extremely useful to know. There are specific properties about each of these that I would want to go deeper into, because there is a lot of difference between dispersion described as standard deviation versus dispersion described as percentiles or interquartile range and so on. But that will take a inordinate amount of time, and I do not want to take everything in one video. Next, measures of central tendency, also mean and median. There is a huge difference between them, and understanding which is useful in which context, and whether you should be using mean or median, etc., that also will be covering in one separate video. Okay. Today, I'll just be describing what these are and how you can get these in Excel as well as in Jamovi. So all of these things can be gotten in Excel also. Remember that. Okay. So, okay, I've described all of these here. I'll be describing this later on. So how to do the descriptives on Excel? You have got all of these specific functions that you can apply, like basically equal to is basically whenever you want to start a function in Excel, right? So after that, you have got specific function that you'll be typing out. And then in the brackets, what are the arguments of that function? The argument of the function is basically the data series that you'll be inputting to get whatever you want, basically. So this is the same format is for standard deviation also, for median also, and for mode. Yeah, this function you need to remember: average, stdev, median, and mode. Okay. It doesn't matter whether you put it as in all caps or all smalls. It doesn't matter. The Excel will do it for you. Next, coming to quartiles, that is percentiles, you'll be applying this. There are two arguments to the quartile function in which you have to put the data series, comma, which quartile do you want? So the first quartile, that is the 25th percentile. Second quartile is the 50th percentile, that is your median. And third quartile is the 75th percentile. Okay, so these are the most commonly used ones. So for 25th percentile or first quartile, you'll be using 1 as the argument, comma 1. And for third quartile, you'll be using comma 3. Okay. Next, standard error, I'll not be talking about now. Variance also, because it's a little more detailed, I can talk about, but I'll not talk about it. Variance basically also is similar to standard deviation, and you'll be doing it by equal to var and the data series. Okay. So I'll demonstrate this to you later on, but frankly speaking, your Excel is, you will rarely be using Excel for all of these descriptives, because you will mostly need to split the data by something and so on, and it becomes a little cumbersome. You have got much more easier ways of doing that, and I'll be describing it using Jamovi. Okay. So let's open Jamovi. Okay. So now that this is open, let's open up a new data set. As you remember from the last video, we'll be going to this 3-bar symbol. Then we'll be pressing open. From that, we'll be going on to, sorry. Yes. Yes. Okay. So this is the data that we were working with last time, in which I described how to change how to fill in the data in the Excel file. This is that same test.xlsx. Now for doing descriptives, you need to go to this exploration tab. In the exploration tab, you will be going to this descriptives. As soon as you open it up, then you can see that the results window has opened up parallelly, and you have got the data entry into this side. Okay, so in this, whatever variables you want, okay, you will be entering it into the variables column. How do you enter it? You basically select each of them. So for faster selection of multiple variables, what I do is I'll select the topmost one, that is age, and I'll be pressing shift. Keep the shift pressed and press the down arrow. So in the down arrow, you're going to select all of them. Then you just scroll down, confirm that all of them have been highlighted, and then you press this side arrow into variables. Okay, so all of the variables you can see have been put into the this one. Now in this, we have got a lot of different types of variables as we have described. Now the one with the symbol A, okay, this is basically a nominal variable according to, like, this is how it has described itself. Okay. Apart from that, you have got age, ASA, and so on, which has been taken by this one, taken by the software as a ordinal variable, but it will use it the same way as you'll be using an interval scale variable. Okay, so you do not need to worry about that. This is the actual symbol for the interval scale variable. This is probably because this has some decimals associated with it, and this does not have any decimals associated with it. And the way these softwares, they treat the non-decimal ones is to treat them as integers, which cannot have decimals. Okay, and the ones with decimals are treated as a specific type of data type that is called double. Okay, double, or which has basically precision, high precision, meaning that it is described as a lot of decimal points. Okay. So we do not need to go into details of all of that. For now, just remember that this A is the nominal one, and rest of them are treated as numeric variables. That's all you need to know. Okay. Now, the thing is that the way you will be describing your nominal variables will be very different from the way you will be describing the numeric variables. So what I'll do is I'll remove the sex from this for now. Okay. And you can see that parallelly on the side, the whatever you want has already been put up. Okay. Now it has got a number of variables, that is n missing, that is the number of missing data points. Then you have got mean, median, standard deviation, minimum, and maximum. Okay. Now in this, you can see that conspicuously there is missing the interquartile range or the other things that we want. Okay. So for that, if you want to increase that, what you will be doing is on the left side, you can see the statistics tab, just press that. Okay. In that, you can select out whatever you want. Okay. Now you can want percentiles. So in this, suppose we do not want the number of data points and the number that are missing. Okay. So we'll just deselect all both of these, and this will disappear. Okay. Next will be standard deviations. The minimum maximum doesn't really help us, so we'll be deselecting both of these also. But we do want interquartile range, that is IQR. Okay. Then we also want percentiles. Okay, now the IQR is not as useful because the IQR is just the difference between your first quartile and the third quartile. Now you're not interested in knowing the difference, but you're interested in knowing what the third and the first quartiles were. So I'll be deselecting this IQR. Okay. Now, okay. So now I think we are done with whatever we exactly need for describing the data, that is mean and standard deviation. These are the two important ones for us. Then you have got median and 25th, 50th, and 75th percentile. Now, since the 50th percentile is exactly the same as median, I'll be removing the median also, right? So now we have a compact data set which is going to describe the numeric variables for us. On top of this, there are other things that you can also get, like you can get variance, which is basically your square of the standard deviation. No, so you don't need that for now. Then there are certain specific things that are useful for you, that is skewness, kurtosis, which will be useful for describing the normality of the data. Also, although nobody really asks for it in common practice, so we'll just let that be for now. But this is important. This normality test is important because this will dictate what tests you do for your data series. Okay. And apart from that, standard error of mean and confidence interval of the mean, both of these can be gotten from this one itself. I'll be describing these when I go deeper into your dispersion measures as well as the nuances of central tendency. Okay. And standard error of mean is practically very useful for calculation of t-test and all. Although t-test and all can automatically done by these softwares, but sometimes some people might ask for standard error of mean for specific variables. You can maybe do using that and this. Okay. Now coming to the next important, the most important functionality, that is split by. Okay, so basically most of the time you will have some groups within which you want the answers to be organized. Okay, so you'll be selecting the group here and putting it into the split by. And automatically you can see that your data is being computed and it will be described in A separately and B separately. These were the two groups that we were talking about. Okay. Now this you have done. Okay. Along with this, what you also need, so what you can do is you can copy this. Okay. Open up a new Excel file and paste it. So now you have got the data as data in the Excel file as a nice, beautiful table that you can maybe paste into whatever you want, basically. Like if you want to make it into transpose, put it into a table in doc file or PPT, you can easily do that. But this is how you export it. Okay. Next, coming to the now, suppose now once we have done this, what we want is we do not want all of the now we want suppose for the sex. Okay. So what we'll be doing is I'm removing all of those variables. I'm putting in only sex. Okay. Now for sex, you have no need for these mean, median and all of this, but what you need is the frequency tables. So basically you select the frequency tables. So in this, now you can see that the data has been organized into female, male, within female group A, group B, and what is the percentage of the percentage of A in female and percentage of B in female. And this is described according to the total number of data points that you have. Okay. So this then you will copy again and then you'll be pasting it into your Excel file. Okay. Now, once you have done this, after this, you can think about plots, etc. But frankly, for plotting, I'll be taking a separate lecture. So for now, I'll just leave it. Okay, so this is how you describe data in Jamovi, and also you learned a bit about the type of variables and some of the measures of descriptives that are possible possible for you as statisticians. So I'll be stopping now. In the next lecture, I'll be describing in detail about mean, median, and the measures of dispersion, what they mean, etc., etc. Okay, so until then, thank you for listening.